Hello kids, in our last class we started the new chapter lines and angles and we have gone through the points line, segment, line and rays, right? So today we are going to start the first exercise of this chapter and I am marking this exercise as exercise 2.1 since it's the first exercise here. Okay, so let us begin with the first question. It is, Rehan marked a point on a piece of paper. How many lines can he draw that pass through the point? Sheetal marked 2 points on a piece of paper. How many different lines can she draw that pass through both of the points? Can you help Rehan and Sheetal find their answers? So, the first part of the question is, I am marking it as the first part for Rehan, that Rehan marked a point on a piece of paper. How many lines can he draw that pass through the point? So, let us say this is the point that Rehan marked on the paper and I am marking this point as R. I am naming this point as R. The question says, how many lines can he draw that pass through the point? Okay, so let us see. 1, 2, 3, 4, 5, so on. Okay, so since we have this point, we can draw any number of lines which can pass through this point. Okay, so the answer is we can draw infinite or any number of lines that passes through this point R. So answer I am writing here is Rehan can draw infinite or any number of lines that passes through this point. Okay, that passes through this point. So kids, we have seen here, since we had only one point here, so because of that one point, we can draw any number of lines which can pass through this. So in case we have 2 points, like in our second case where Sheetal is there, and what she is doing is she is marking 2 points on the piece of paper, and we have to see now that how many different lines she can draw that can pass through both of the points. So now Sheetal has done what? She has taken 2 points A and B. Okay, she has taken A and B, and now she is trying to draw different lines which passes through both. Since it is passing through both the points, so there would be only one line. Okay, there would be only one line which will pass through both the points because it passes through both the points. And in the first case for Rehan, we had only 1 point. So if we have only 1 point, we can draw any number of lines. But if we have 2 points, then there will be only one line which will pass through both of them. Okay, now I can represent this line as, I can write this line as AB, or I can also write it as BA, right? This we have learnt in the last class. Now, I hope this is clear, and we will move to the next question. Question number 2. Question number 2 is, name the line segments in figure 2.4 and then which of the 5 marked points are on exactly one of the line segments and which are on the 2 of the line segments. So kids, first of all, in this figure 2.4, how many points we have? Let us see how many points we have. We have L, this is first point, M, P, Q and R. So we have 5 points here, right? So we have 5 points in this figure, and next is which of the 5 marked points are exactly, okay, sorry, the first question is name the line segment. So kids, we know that line, what is a line segment? A line segment has 2 fixed points. It has a fixed start and fixed end, and it is of finite length. Okay, so now we have to name the different line segments which are there in this. So I'm marking this as A part and line segments. What are the different line segments? First is LM, because this is the starting point, this is the end point, and it has a fixed length also. So this is LM. I will write LM, and above that for line segment we use a line, right? This is first. Then MP. Same, we have M as the starting point, P as the end point. If we start from here and like this. Next one we have PQ. PQ line segment. Then we have QR. LM, MP, PQ, QR. QR. So these are the four line segments. LM, MP, PQ and QR. These are the four line segments in this figure. Okay. Coming to the next part of the question. Which of the five marked points are on exactly one of the line segments? So here we have 5 points L, M, P, Q and R. So the question is, which points have exactly one line segment associated with them? Okay. So if I see L, L is associated with this line segment LM. Okay. But if I see M here, it is connected to two line segments because it is connected to LM and it is also connected to MP. Similarly, if I go to P point, this is connected to the line segment MP and to PQ also. So it is also connected to two line segments. Coming to Q, Q is connected to PQ and Q is also connected to QR. So it is also connected to two line segments. And then we have R. R is connected to only one line segment, that is QR. And the question is that which of these 5 points are exactly one of the line segments. So L, it is connected to LM, and R, which is connected to QR. These are the only 2 points which are connected to one of the line segments, right? Because all other, they are connected to 2. Here M is connected to these two, P is connected to these two, Q is connected to these two. But L and R, they are only connected to one line segment. So the answer is L and R are connected to only one line segment. Okay? Segment. Next, C part of the question is, which are on the two of the line segments. So we just learned it was M, P and Q. They both are connected to two line segments. So M, P and Q are connected to two line segments. Okay. Next is figure 2.5, which is this figure. And is T the, name the rays shown in this figure. We have to name what all rays are here. And then is T the starting point of each of these rays. So we have to determine if T is the starting point of all the rays in this figure. Okay, so let us try to do this question. But before that, we should know what is a ray. And that we have already done in the last class. A ray has a fixed starting point, but it has no end point. Okay, it can be extended infinitely in one direction. It has a fixed starting point and it has no end point, no fixed end point. It can be extended infinitely in other direction, in one direction. And the other thing was it has no finite length also. Okay, so these were the two properties of rays. Now coming to the question, name the rays shown in this figure. So kids, I'm marking here with red. The first ray is TA. This is one ray. It is starting from T and it is going to A and extending in this direction. So the first is TA, this ray. Okay, then we have TN. And we have TB also. This one. Also we have this ray NB. It starts with N and it is going to this direction, right? NB. So I'm writing the different rays are TA. How do we represent A? Fixed point and a arrow in one direction. It is the representation of ray. Second one we have TN. Third one we have TB. And fourth one we have NB. So these are the rays TA, TB, TN and NB. Okay, these are the different rays. Now, next question is T the starting point of each of these rays? No, because for NB, this ray, N is the starting point. Okay, so answer is no. For the ray NB, N is the starting point. Okay, N is the starting point here. Now, next we have is draw a rough figure and write the labels appropriately to illustrate each of the following. What we have to do is we have to make different figures here according to the question given. Okay, so let us try to do this. Answer number 4. We have first part is OP, which is a line because it has arrows on both the sides, and OQ, which is also a line. They meet at O. Okay, so we have to make two lines which meet at O. We can make it in any form. So I am using this. I have a point O, and this is the line. This is the line. This is OP and this is OQ, and arrow here and arrow here, and they are meeting at this point O. Okay, they are meeting at this point O. This is a figure for A part. Next is XY, which is a ray because it has arrow in only one direction, and PQ, which is a line. They intersect at point M. So we have two things. We have XY. So let me try to make this as X starting point. This is Y, and a line PQ. So this is a line P and Q, and they intersect at the point M. So this is the point where they are intersecting. Okay, this is for B part. Next, coming to C here is line L contains E and F but not the point D. So first of all, we have to make a line L. So let us try to make a line L. Let us say this is a line L. Now it contains the point E and F. It has 2 points, E and F, but not the point D. So that means we have another point somewhere here which is not on this line, but it is present. Okay, so this is a line L which has arrows on both the sides, and it has 2 points on it, E and F, and then there is another point D which is not there on this line. All right, now coming to the D part of this question. It says point P lies on AB. So AB, so we are making AB here, and there is a point P which lies on AB. This is for question number 4. Okay, I hope this is clear. We should know these symbols first, that this is a symbol of line, this is a symbol of a ray. Okay, and then we would be able to do this. Okay, and this is meeting, so I could also draw it like this. Okay, this is one way to draw this. Otherwise, I can also draw it something like this, that this is a O point, this is a P point, This is a Q point. Okay, and they are meeting here. So anyways, we can do it. Next, we will come to question number 5. In the figure 2.6, we have to name the 5 points, a line, 4 ray and line segment. Okay, just give me a moment. I'll just drag it down and we'll get a space here for this question. Okay. Yeah. So answer number 5. First part is we have to tell the 5 points. So 5 points are very simple: O, E, D, C and B. Okay. So I'm writing O, E, D, C and B are the points in this figure. Next, a line. We have to tell a line. So what is a line? A line has 2 arrows marked on it. So this is a line. I can say DB is a line, or you can also say, which you can also write as BD. Okay. If we read from here, it is BD. If you read from here, it is DB. Next, we have to tell the 4 rays. So kids, what are 4 rays? We know the starting point, but the end point is a arrow. It is extended. So let us start from here. OE, OD, OB and OC. Right? OE, OD, OE, OD, OC, OB. OC and OB. These are the 4 rays because the starting point is O and then they are being extended infinitely in the different directions. Next, we have the D part, which says the 5 line segments. So line segment means fixed points, fixed length. So the first line segment, if we see here, is DE, DE. Second is EO. Next, OC. Next, OB and DB. These are the 5 line segments: DE, EO, OB, OC and DB. Okay, these are fixed points and they have fixed length also. These are the line segments. So this is done. So kids, you need practice to do this. You should understand the difference between a line, ray and line segments, which we have done, and then you would be easily able to differentiate between these. That how we have determined it is that this is a line because it can be extended infinitely with arrows, and then second one for a line, that was for a line, and then for a line segment it has fixed length and they have fixed starting and end point, and then for a ray it has a fixed starting point and then it can be extended to any direction infinitely. Yeah. Okay, now I am coming to the last part of this question, which is question number 6. That is, here is a ray OA. So we have this ray because this is the starting point fixed and this is the we can extend this infinitely B. Okay, it starts at O and passes through the point A. It passes through this point A. It also passes through the point B. Yeah, so we can very well see in this diagram the starting point is O and then we have a ray which has 2 points A and B on it. It is mentioned here. Now the first part is, the first part says is, can you also name it as OB? Yes or no? Answer number 6, A part. So kids, since the starting point of this ray OB and OA, it is same and it is a ray which can be extended infinitely. It has no end point. So that means yes, we can also name it as, yes, we can name it as OB. OB. Because because B point lies on the ray. Okay, and the starting point is also same as that of OA. Okay, and the starting point, that is O, is same. So we can say it as OB. See, because here it can be extended infinitely and it is on the same ray. It starts at the same point. So we can also call it as OB. Okay. Next, B part is, can we write OA as AO? Can you write OA as AO? So no, we cannot write it as AO because the starting point will be A then. But the starting point of this ray is O. So no, we cannot write it as AO as starting point is not A. Okay. Starting point is not A. Okay. Being a ray, it's a ray. Being a ray, starting point is fixed. Starting point is fixed, which is O here. O in this figure. So I hope this is clear. I will explain you again. See guys, this is a ray. Here we are dealing with ray which has a starting point O. Okay. So now what it is saying is, can we write this OA as AO? So the answer is no, because O is a fixed point here. But A, it is not a fixed point. It is not the starting point here. So we cannot change the starting point of a ray. Since we cannot change the starting point of a ray, we cannot make it as AO. So I have written the same. We cannot write it as AO as the starting point is not A. Being a ray, the starting point is fixed, which is O in this case. So we cannot write it in the opposite way. And also, can we name it as B, O, OB? This we have done. Here, the starting point is same and this B lies in the same part of the ray. So yes, we can write it as OB also. Okay. So I hope this is clear, kids. And next, we will begin with the next part of this chapter.